The x-axis is horizontal. Is the horizontal axis of the rectangular coordinate system. It determines the ordered pair, which is located on left and right of the origin. The y-axis is the vertical axis of the rectangular coordinate system. It determines if the ordered pair is located down or up from the origin. Okay, so right here is the x-axis, and then here's the y-axis. So the instructions are right here. They're in bold, so kind of notate that throughout the book. The instructions are in bold, and they follow what's below. Okay, plot a point as defined by the ordered pair. So the first thing I want to go over is the quadrant. So you have quadrant 1, quadrant 2, 3, and 4. Sometimes you see it notated in Roman numerals, so that means 1, 2, 3, and 4. And it goes counterclockwise. And then we're going to talk about the values that are found in each quadrant. So within the quadrant, you're going to have a positive x, a positive y. Quadrant 1, quadrant 2 will have a negative x, positive y. Quadrant 3 is going to have a negative x, negative y. And then quadrant 4 will have a positive x and negative y. Let's see what that looks like. I think I decided we're going to do all these. Okay, so I'm going to say London is negative 6, 9. So to find London, it's right here. We start in the center, we go to negative 6, and then we rise up. And we see what number that is on the y-axis. It's between 8 and 10, so that's going to make it 9. So again, you see how that's negative, positive. So then you have a negative 6 and a positive y, which is 9. The next point is going to be 8, 8. That's Berlin, so it's right here. And then it's going to be negative 4, 4 for Paris. Negative or 3, negative 4 for Bern. Madrid will be negative 8, 8. This one's a little bit confusing. So you go negative 8 and then down negative 8. So negative x and negative y. And then in Rome, 7, negative 9. All right, so down here, we do have like A through H. We're not going to do all of them. I feel like y'all already got that. So you're going to still plot the point. So the scale, if you notice, these scales are different. This scale counted by 2 on each axis. So we had to kind of determine the number in between, right? Even though it's not indicated. So sometimes you'll have all the numbers indicated. Sometimes you'll have like, we'll skip count like in multiples, like by 2s or 5s or whatever. So let's keep on going. So we have B. B is going to be negative 4, negative 6. So it goes negative 4, negative 6. That's B. Oh, I missed A. Sorry. A is going to be 2, 3. So I'm going to go start from the center, 2, and then up to 3. Now, C is very important because C, we call this the y-intercept. Let me rewrite that. Y-intercept. So we go, the y-intercept is because it's actually on the y-axis. So when it touches or crosses the y-axis, we call it a y-intercept. And then the pattern of this is that a y-intercept leads with a 0 for the x, and then it's followed by a number for the y. And then D is also pretty special because we call this an x-intercept. So it's going to touch or cross the x-axis. The pattern of this one is that it leads with a value for the x and it follows with a 0 value for the y. And then you have E, which was 5. Oh, I mismarked that one. 5, negative 2. So that one's going to be 5. And then down to negative 2. Right here. E. And then F, again, is pretty special. Look at F. F is the origin. So y-intercept. X-intercept. And then 0, 0 is what we call the origin. Origin is where you start when you are trying to plot points on the graph. So A, or number 3, it says, name the quadrant of the axis where each point lies. So again, you have the signs, so we don't really even need to look at the we don't need to plot the points. We just need to look at the signs. And then again, follow the pattern for the y-intercept and the x-intercept. Okay, so I have a negative x and have a positive y. That's going to be quadrant 2. We'll skip around. Let's do C. I have a positive 2 and a positive 6. That's going to be quadrant 1. All right, now let's look at D. It's a good one. I have a 0 and a negative 5. Okay. If it starts with a 0 and it's followed by some number, doesn't matter if the number is positive or negative, it's automatically a y-intercept. So name where the axis where the point lies. This is going to be the y-axis. It does not lie in a quadrant. Then you have 3, 0, 3, and then 0. You have a number and then you have a 0. This is going to be an x-intercept or an x line on the x-axis. We can actually plot these two. I think that'll help some of us. So this one right here, 0, negative 5. Start 0. Start 0. And then go down 1, 2, 3, 4, 5. So it's going to be 0, comma, negative 5. And then this next one is 3, 0. So start in the center. Go 3 right. So that's 1, 2, 3. And we don't go up, so it stays there. So it's going to be 3, comma, 0. Again, they're both intercepts. All right, so when we identify the x-intercept, so it's going to touch or cross the axis. So an intercept will touch or cross an axis. We can also call it the INT. That's what it is right here. So the first one, the x-intercept is going to be right here. That's the only one. And then the y-intercept is going to be right here. So that's going to be 3, comma, 0, 0, comma, 3. You can have multiple x and y intercepts. X-intercepts, we have 2 of them here. I have one on the left, one on the right. Y-intercept, I have one right here. So then we get negative 2, comma, 0, comma, 2, comma, 0. Negative 2, 0, 2, comma, 0. And then down here, we start the 0. So it goes 0, comma, negative 4. 0, you don't go up or down, and then you just go, I'm sorry, you don't go right or left, so you start at 0, and then you go down negative 4. Let me move these up. You get the idea. Those two, they're not gonna, oh, I can't move them up. They go right there with the x-intercept. I think they're better down there. X and y intercepts. So to find the x and y intercepts, first we need to realize that the ordered pair, x is a value, y is a value. So we're not going to do number 7, but we are going to complete number 6. So to find the y-intercept, I'm sorry, the x-intercept, you're going to substitute 0 for y. And then we're substituting to the problem that's given. So it's 4x minus 2 times 0 equals 12. The 0 cancels out the 2, so it's 4x equals 12. Divide both sides with 4. X equals 3. So that's going to be, again, our x-intercept when we put together these values, this value here and this value here, we're going to get 3, 0. And then to do this one, it's going to be 4 times 0 minus 2y equals 12 minus 2y equals 12. Divide both sides by -2, everyone. So when you divide by -2, you're going to get a different sign. Y equals -6. So that makes our y-intercept 0, -6. Because you substituted an x right here. Right there. This is talking about domain and range. Domain is all possible set of independent values in the relation, which are the x values. The range is all possible dependent values in the relation that can reduce the domain values of y values. Okay, so let's go over this some more. So you have x, and then you have y. So we're just going to make a table with all the things that x and y can be. So our definition says our x is our domain, and then it says our y is our range. If we go back to the definition, it says that x is the independent, y is going to be the dependent, and then x is also going to be your input, and then y is going to be your output. Okay, x is horizontal, y is vertical. So let's talk about domain and range. So this is called a set. It's identifies a set because it has those little squiggly lines at the end. And then it's giving us ordered pairs, but it's defining them with some sort of like symbol. So, or 5 gallons equals $15. So this is the domain and range of a relation of the number of gallons of unleaded gas purchased and the cost paid by different consumers at the local Quick Trip. So again, the x is first, and then you have y. So an ordered pair is x, y. And then it's named a set when it has those lines around it. So this is a set of an ordered pair. So 4 ordered pairs remain here. So we have x's are always first, and then y's are second. Now, when you're naming domain and range, I just like to place them in the order that they are listed. I don't like to rearrange them. I know that some instructors will ask you to rearrange them from least to greatest or greatest to least. I'm just not going to do that for this example. So our domain is 5, 10, 12, and 20. Our range is going to be 15, 30, 36, and 60. And if you notice, it has the set notation around each.